Welcome. In this video lecture, I am going to talk about the concept of yield. So there are three types of yield. One is known as the final yield, okay, and the second one is known as first pass yield. It is also known as right at first time yield, okay, and the third one is known as rolled throughput yield, right? So there are three type of yield, and we are going to discuss how we can calculate the final yield, first pass yield, or a right at first time yield, as well as the rolled throughput yield, and how they are different with each other. And in terms of lean, or in terms of the quality management, what kind of yield we can report while we are talking about the process improvement point of view. Okay, let's first discuss the final yield, and this yield is known as the acceptable pieces at the end of the processes divided by the pieces at the start of the process. Okay, so which mean we can incorporate the rework unit which we have done during the different multiple processes, and we can consider those as an input to the next process, and we will observe that initially we have input the 50 units, and the final output unit after processing all these three processes we obtain 37. So we can say that the final yield of the entire process is going to be 37 by 50, which is the final yield, which means according to the final yield, which also incorporated the rework unit, which mean only excluded the scrap or the defective units. So that means it is saying that 74% of the product we are producing conforming as per the requirement of the customer. Okay, so which means there is no product which is rejected, no product is scrapped. We have done some rework. So how we can calculate the final yield step by step? So as you can see, this is the process flow diagram of our process. So we have given the input of the material of the 50 pieces, and we have done the process one, and we found that out of the process one, the output is forward defective unit, which means the scrapped unit. Whereas after doing the rework on the 6 units, we make it as according to the requirement of the customer. So which means the output of the process one is, after incorporating the rework, is 46. So that means the final yield of process one is going to be 46 divided by 50, which is 92%. Okay, after multiplying by 100. Now if I'm going to talk about process 2, now the input is basically for the process 2 is 46. Okay, so there is no scrap, but there is 12 rework, so which means the output is also going to be 46, which is 100%. But if I'm going to talk about the final yield up to process 2, from start to up to process 2, then it is going to be 46 divided by 50, which is again 92%. Okay, now if we go towards the process 3, so the input is 46, but 9 are going to be scrapped. It is saying, so there is no rework, so the output is going to be 37, because 46 minus 9 is going to be 37. So the final yield of process 3 is going to be 37 divided by 46, only if we are talking about the process 3, which is 80.4%. But overall, if I'm talking about the entire process perspective, the final yield, as we have discussed earlier, that is going to be the total conforming unit divided by the total input, which is 50. So the final yield is 37 by 50. So which means in a final yield, we only excluded the scrapped or the defective units. We do incorporate the rework units. So after correcting them, we can use them as calculating the yield, okay, or to report the yield. So the next type of yield, which is known as first pass yield or first time yield, it is also known as throughput yield, it is also known as right at first time yield. Okay, so in this type of yield, we are not incorporating neither scrap, neither we are incorporating the rework. So we are only considering only those pieces which we have produced right at the first time. So how we can calculate the first pass yield, or the you can say throughput yield? Okay, or right at the first time yield, that is up in a process one, we have given the input 50, the same process. Neither we are going to incorporate scrap, neither we are going to incorporate reworked while we are reporting first pass yield. So the output is 40. So the process one yield is going to be 40 divided by 50, which is 80%. Okay, but practically we do rework. Okay, so the input is going to be 40 plus the rework unit, which is 46 for the process 2. Okay, so but for the reporting purpose, for the first time yield, we are neither incorporating scrap, neither we are incorporating rework. So 46 minus 12 is going to be 34. Okay, so that is 34. So 34 divided by 46, that is approximately 74%. So again, practically we do incorporate the rework unit as an input to the process 3. So that is 34 plus 12, 46. 46 divided by 37. Okay, so 37 divided by 46 is going to be 80%. So this is basically the first pass yield of every particular process. So now in order to calculate the roll throughput yield, which is basically the entire process first pass yield, or which is known as the roll throughput yield, how we can calculate that is going to be calculated as first pass yield of the process 1, first pass yield of the process 2, first pass yield of the process 3. So if we are going to multiply those yields, so that is going to be the roll throughput yield, or right at the first time yield of the entire process. Because in a roll throughput yield, neither we are incorporating the scrap, neither we are incorporating the rework unit again. So which mean only approximately 47.5, which mean approximately 48% of the entire process is able to produce zero defective units. Okay, so that means right at the first time we are producing only 47.5% units. So the remaining, either we are doing the rework to make it correct, or either they are the scrap. So I hope you got the idea regarding the three types of yield. So in terms of the quality management, which type of yield we have to report for the entire process, that is the roll throughput yield. And obviously, if you want to report to the every particular process, that is going to be the first pass yield of every particular process. So thank you so much. See you in the next video.